Okay, so the last video we talked about the properties or rules of logarithms. So now they have this scenario set up where you know the value of each of those, but they give you this new scenario and you use the given values to solve. All right, so I'll give an example of what this means. So this says log 3 divide 2. Well, if I look up there, there's not a log 3, not a log 2. But what I do notice is I can rewrite 3 divide 2 as 12 divide 8. Right? 12 divide 8. They each have a 4 in common. That's 4 times 3. That's 4 times 2. Yeah. So log 12 divide 8. And then remember, for the properties of logarithms, when you divide the argument, it expands to subtraction. Now, we can take what we know. Here's log 12. So log 12 is 1.1. Log 8 is 0.9. (1.1) subtract 0.9 should be 0.2. So right here we can say log 3 divide 2 is 0.2. Or we could go ahead and rewrite it there, but there's no reason to do that. Okay, we're going to go to the next one. And I still get irritated that it doesn't look like that. So we have log 1 over 64. Well, if I look up here, 64 is the same as 8 squared. So I can rewrite this as log 1 divide 8 squared. Well, remember, division expands to subtraction. Now, what also do you know? When a log is raised to a power, we're going to rewrite that as multiplication. All right. So now, okay. So before we go further here, I need to remind you of a couple things that I did not tell you before, a couple of additional rules. So, multiplying arguments expands to addition. Dividing arguments expands to subtraction, the stuff we've done. Raising a power expands to this. Okay, what I didn't tell you is log of any base 1 is equal to 0, and log of any base of the argument the same is equal to 1. And log of 0 is undefined. So log of any base, positive 1, is equal to 0. Log where the base number and the argument number is the same, that equals 1. All right, so the reason I needed to go over that, look at log of any base of 1 is 0. So right there, we can write that as 0. And then this, that's a subtract sign. and this is 2 times. Well, right up here, we have log 8 is about 0.9. So now we have 0 subtract 2 times 0.9 should be 1.8. And what I didn't tell you over here, we should be using approximation symbols because of all of this stuff above is approximation symbols. So right here, we would say is approximately negative 1.8. All right, we'll keep going. $768 is not very visible. So the first thing in your calculator, don't have to write this down, go ahead and try 7 times 8 times 12. If that doesn't equal 768, times 8 times 8 times 12. If that doesn't work, try 7 times 8 times 8, 7 times 12 times 12, or 7 times 7 times 12. Something like that. Keep trying until you have what it is. And what we end up with is, and that's, remember that invisible base is 10. It ends up being 8 times 8, which is 8 squared, times 12. Those two are the same as log 768. Remember, we now have a multiplication. We also have an exponent. So multiplication expands to addition. And this exponent can be brought around in front. So 2 times the log of 8 plus the log 12, the argument 12. Well, now we can fill in the numbers. Log 8, so 2 times 0.9 plus log 12 is 1.1. So this right here is 1.8 plus 1.1 is about 2.9. And maybe I'm not right on that. Yeah, that looks right. All right. Let's see, 64. We have a log 8 again. So we can rewrite this as log 8 squared. That looks weird. We've got to divide. Divide expands to subtraction. So you've got log of 8 squared. That 2 is going to come around in front. Subtract log 7. So 2 log 8, 2 times log 8, subtract log 7. Well, now we can just put in these values. So 2 times 0.9, subtract 0.8. So this is 1.8, subtract 0.8. We've got approximately 1. There you go. So they just become these puzzle pieces. And again, these that we've done, these are the easy versions. Some of them get very complex. They're all manageable, but they're very complex. All right, that's going to be it for this video. And then for the equation ones, I'll do that in a separate video.